So, hello everybody. Thanks to join so early to listen to me. That's surprise. First of all, who am I? My name is Luca Pizzamiglio. I'm an Italian guy working at Trivago. I'm a FreeBSD enthusiast. I use FreeBSD at least for 10 years now, and I received my port commit bit in August 2017. What I'm doing usually is trying to look for new use cases for FreeBSD. I really believe FreeBSD is a very solid platform and can run basically everything. Specifically in Trivago, I build packages, customize stuff, and so on. A note, it's early, Sunday. I had the ability to provide gadgets, you have socks. So every time you have a question, you receive a sock. So the first 10 questions, so don't be afraid, please speak out, make this presentation more interactive. Help me. it's really for me out also. So this is for today. We'll talk a bit about JS and pod, what pod is, something I presented 2 years ago here. What is a service mesh, or what I believe a service mesh is. What is a pod image, future work, and then your question. The pod framework is something I started more than 2 years ago, actually. The ambitious goal was to basically there is no Docker, we know, on FreeBSD, at least not natively, but actually is a really nice pattern, or at least something that is quite easy to use. But in FreeBSD there was actually no container model in general. So say, why don't you try to do something similar using all the technologies that are already available, like ZFS, jail, PF, VNet, RCTL, CPU set, and so on. So I came out with this framework as a set of, basically it's a tool that allows you to manage jails, dataset, I would say pretty easily now. At that time was quite rough. But yeah, that was the logo at that time. So pod comes from a pod, it's not the other meaning of pod. This someone else suggested. And that was basically the state at that time. And how that fit in here. Who does know what a service mesh is? Or use? Wow. So I have to explain the best of my capabilities what a service mesh is. A service mesh in general is an abstraction where a developer here can submit basically a job, or then we'll see what a job is, to this very big black box cloudy thing, and then the user can just use the service that is exposed by this job. I will go a little bit in detail. This is not like, it's similar to Kubernetes, but it's not Kubernetes. So basically, the developer has a job description where it specifies which container to use and which pod should be exposed, which type of services is that, and so on. Here we have a central point, in this case the orchestrator. It received this job description and they say, okay, you want these containers up and running. It looks for in the worker cluster, so we'll basically transfer allocate or orchestrate basically the execution of these containers to the workers. The workers will download the container images. There will be spawned basically those new containers. The service will be up and running, and that is one side of the story. Then if it's a network service, you have service discovery something, server, basically, we use console here. And what the orchestrator does will register your service here, and say, okay, now I decided that your service is running on this machine, exposing the port. I mean, it's running on ports 1, 2, 3, 4, 5, whatever. So this information are registered now here. So the service discovery will know, okay, there is this service with this name that is running there. And what it's also doing is continuously checking if the service is up and running, so the health status of this service. And this is the so-called control plane. So now, theoretically, if you want to reach the service, I mean, the orchestrator decides where the service is running, so you don't know exactly where it is. So you have to basically interrogate the service discovery. And this is called, I guess, the control path. So basically, you can know basically where your services are running. And you have another element, is called is a proxy or a layer 7 load balancer. This load balancer or this proxy, you can configure it basically to say, okay, or when there is a user that wants something, look for where this service is running. So basically, the list of the backend is continually updated to know where all the services are running. So it's oh, you want this service? Boom, I reroute basically all the traffic to the proper node, but they get the information here. And every time there is a new service that is, if the same service is replaced, so the old container got destroyed and a new container is running, for instance, here, the information is updated in the service discovery, and so the proxy can get updated information and reroute the traffic in a different direction. I hope I explained myself. I'm not really a super master of this all elements. Any question? Cool. You get get us.
It does not seem a FreeBSD upset to me, because images, nomad, console, and there are product names.
So to repeat the question, this doesn't seem FreeBSD things to me. Yeah, that of course that was the problem. Actually, those are programs that run everywhere. They are mainly, I guess, all of those are Go programs. Yeah, that's actually the point. How can you have something like this on FreeBSD? And that is the solution that I'm presenting now. As you see, the real issue is this container images. There is normally no such solution that has used these names. And exactly that was what is really needed. The features that was really missing was the ability to deal with images, so creating and download the images. So you need to create and export an image. You need a image registry. I mean, imitating Docker, okay, you have to create a Docker container. You need Docker Hub, and then the ability to download and then import an image. That was the set of features that we worked on. But more importantly, what is really different is the paradigm, how you work with those kind of, I mean, the workflow is really different. We are used to create JS directly on the machine, and then you configure them and you let them running. And the developer will just, I don't know, just give you I don't know, the PHP code or the Java code, whatever is running there, but you are directly managing JS on your final machine. So the paradigm here is different. Someone is working on the image creation, so in the EJL image, and someone else is deploying it. So the paradigm is very, very different, and also how the set of tools that you need is different. It's an almost unexplored area, I'd say, and sorry. I will discuss before the deployment of the jail on the available nodes, so to make that feasible, and then we'll discuss about how to create an image and all those things. There is already a lot of complexity all around. I mean, a lot of new names, new components, things that are going there and there. So the first implementation of pod as basically a jail was composed by multiple datasets. There was the base that was mounted in read-only and shared with other jails and so on. For this kind of scenario, when you have those moving parts, it was too complicated. So I decided, okay, just go to one single big ZFS dataset where I put everything there. So it's easier than to create images. How I export a pod. Basically, you create a pod, basically a jail, you customize it, you put the software that you want, you take a snapshot, and then with ZFS send and compress tool, boom, you create an image. So basically what you want inside your jail. And then you have a file. A file is easy to move. To import a pod, well, is the other way around.
This implies that only ZFS can be used.
The question is, only ZFS is used? Yes, ZFS is mandatory.
Okay.
I don't support other thing. If you if you want to use a different, please support a patch. That means submit a patch, and we're happy to extend support. But I mean, ZFS, the whole pod framework is heavily based on ZFS because I have all the nice feature, snapshot, rollback, and everything's there. I said to import a pod, so basically when you download a file, then you can just uncompress, ZFS receive, boom, you have the same basically content somewhere else, and then you can clone the snapshots. I use the clone here because if you have one image, then it's if this image is reused. Imagine an Nginx server and you have the same Nginx with different configuration. It's easier than to clone it and just change the configuration file than to untar again and do a ZFS receive. So that's basically is a slight short optimization. Question so far? Other question?
Did you try to use Beehive, for example? Not just jail, but Beehive.
Question was if I try to use Beehive. No, because it misses completely the point. I mean, jail is very, very light. Beehive is not that light. I mean, Beehive makes sense when you have different operating system that you want to run on FreeBSD host. If you have the same operating system, use jail. I mean, I want to I'm focused on native support. I mean, it has to be native. It's really faster. If you have Beehive, you don't have the same performance because full virtualization. With jail, you have a light virtualization. So it's just the operating system side. So. I'm waiting for your patch on that topic. So why we choose Nomad to try to implement this service mesh dinosaur? Nomad console are, let's say, FreeBSD friendly in the sense that they are already in the package system. So you can just install Nomad and console and run and have them up and running. So console is the service discovery and Nomad is the orchestrator, basically. Moreover, Nomad has an internal structure that allows to add additional driver. And a driver is something that is basically supporting a different type of containers. So there is a driver for Docker container, a driver for, they call it, this Java thing means that basically you have a jar tarball and then it's executing the JVM right away. So different types of containers. And what happened here is, why can we not write an additional driver to let Nomad interact with pod? So Esteban, that I see here, present, a colleague of mine just developed the driver. I mean, try to create this bridge between Nomad and the pod framework to interact with JS. So the driver is already available. You can install it on your own. So it's, I would say, mature product, but stable enough. And this is the job description. I will go through that a little bit. This is a very easy example, even if it's very long. You have on top the name of the job. The job it's a service. Then you have the concept of group, because a service can be composed by different containers, so you want to join them to provide a service. In this case, the group is called example group, what a fantasy, and is composed by only one task. It's only Nginx pod. And here you specify the driver, saying the driver is pod. Then Nomad will look for a worker that supports pod and will be able to execute a jail in that way. I will just jump here. This is the part that was strictly part of the driver. So basically you say in the configuration where to download your image. You say the name of the image, the version. The command is basically optional, but it's the entry point of your jail. What is the first command that's to be executed when the jail is spawned? Then we have here, that's the service part. So that is all the information that you give to Nomad to spawn the jail. And this part, the service, is what to register to console. The name of the server will be web example, for instance. And then you see this port HTTP, port HTTP here, is meaning that the port 80 in the container will be mapped with a different port outside. There is an automatical PF redirection rule that is injected to the node. And this new information will be registered in the service. So we will see in console there will a different port. Locally, the jail will have an Nginx running on port 80, but then you have a PF rule that makes the redirection. And in console you will discover basically where this thing is running. Questions so far? Yeah.
So this is like the pod registry. It's still out of the. I mean, I didn't understand how you put the image in the pod registry.
Yeah, the pod registry, there is a slide later. I mean, the question was about what is this pod registry? Is a web server with files. There is one slide exactly on that topic. It's complicated. It's all the second part of the was about that. It seems easy, but it's not easy. I mean, if you think why I'm not using IOCage or other jail frameworks that are out there. First of all, because I can do my own. It's open source, so you can do whatever you want. Now, being serious, it doesn't work. There are features. I mean, a container has something different from a normal jail. For instance, this command in Nginx is not forking in background. What it means that if you use that type of command with jail, with the jail command line, the jail command line won't return because the first command is basically executed by the jail command and is just keeping still your shell. It's not returning. The jail has this standard assumption that the command, the exec start of the command that you gave, basically at a certain point will fork and will return. In this case, it's not the case. I mean, usually containers are working with blocking commands. So basically, they keep Nginx is spawning and they're serving directly web traffic. Period. It's not forking, and that it creates a series of issues. In this case, for instance, the post start hooks are not executed at all because what the jail command is doing is just working like create the container, spawn the commands, wait till it's over, and then executing everything that is after the post start. The post start is never reached because the command is keeping, basically is not returning. And a nice thing that is nice, yeah, it took me some time to discover, is usually those containers are ephemeral, means that if the process inside the container disappears, the container disappears itself. Jails are by default persistent, so if there is no processes there, the jail will stay. And IOCage, for instance, only support persistent jails. the no persistent parameter is also applied by jail start as a post start hook. And it didn't work, basically. I have to find some weird way to be able to have this no persistent flag applied even when a command that doesn't return. Last but not least, jails do not clean up themselves. You know that there is the post stop hooks or the pre-stop hooks and so on. If you have a not persistent jail, you mount your devices, you create your PF rules, then the jail disappears. Come on, you have to clean up. But you don't have any notification that the jail disappeared, or you don't have any way to register a callback. What you do usually when you call jail -R, that is the jail stop, is the command that is executing those hooks. So say, okay, the command said I have to stop this jail, so I run the hooks, I stop the jail, and then I run the other hooks. But if it's not persistent, the jail will just vanish. And there is no centralized daemon basically that is controlling that what happened with the jails. They are just, it's an internal operating system structure that just is like when a process is going away, you don't get any notification per se. We solve this basically inside Nomad. If Nomad has to control that the containers are up and running, if it's not running, it's just calling a pod stop and it clean up basically almost everything in that way. But we don't have generically a way to clean up not persistent J. Questions so far? It's clear. I'm too fast.
One more question. For that can I run multiple, like database server or FreeBSD, whatever, before Nginx?
Can you repeat the question? Can you run?
Yeah, something that demonized, like database server or FreeBSD.
You have to avoid, the question was if you can run something that doesn't demonize. You have to change your command line to avoid that it's demonizing.
For example, you're running Nginx at the end.
Oh, no, so yeah, yes, you can.
Run other services that...
So the best practice in this world is to have one process per container. So for instance, we have a Redis instance, and the exporter, that is just basically another program, is running in a different container. Because if one container dies, you just replace this and you don't replace the whole service, basically. There is a common best practice in this way. Technically, you can. It's suggested not to do it. But yeah, you can put more. You can create your own script and spawn different stuff. The point is that the last one shouldn't return. Network. Currently, we support two network configuration. One is the so-called host, meaning in jail jargon is inherit. So basically, you're using the machine network stack. Or the other one is the public bridge, meaning that you have an internal bridge. Every jail has a VNet, its own stack. It receives one IP and is exported outside. There is a NAT that is showing everything, and you have a redirection rule for every service that you want to expose. And those are supported both in pod and in Nomad. In pod, we had also other two network type configuration. One is the private bridge, that basically works exactly like the public bridge. So basically, you have one bridge and you attach your J's there. But the public bridge is one for all of them. With private bridge, you can have a bridge only for a subset of J's. So I have 3 J's, I want them isolated. So you can have dedicated bridges just for this type of, for your work. We want to add this to Nomad as well. So it makes sense, for instance, for a group, you have 3 different J's. You don't want them to be on the same unique bridge for many reasons. Currently, we have a small issue because the driver works at the task level, but the bridge works at the group level. So it's one abstraction level above. And apparently on Nomad 0.10, there is this ability to have something at that level, so we have to figure it out. I mean, currently it's already working with the public bridge, but if you put, I don't know, 200 J's, then this bridge will be overloaded and probably the performance degraded. So this is an area where we want to improve. The last type is alias. This is the typical jail way on doing things. So basically you assign a static IP to your jail, and that will be an alias on your network card. In this dynamic cloudy environment, it doesn't really fit well because you have, I mean, you can theoretically have this jail that is moving from one node to the other, and this IP will follow. But it means that you can only have one instance of that container. You cannot have multiple. I mean, this cloudy thing is designed to provide you horizontal scalability. So if you need more horsepower, then you have, instead of 3 web servers, 5 web servers, 10 web servers. And in this case, we are limiting to 1 because there is only one IP that you can assign. And also when you do, when you want to spawn, I don't know, you want to respawn the same, I don't know, there is a new version of the web server, so you have to redeploy your job. Well, you have to remove the former job, redeploy someone else, and then you have a small downtime between those two times. So I don't know if it's really something we want to pursue. I'm still undecided. Can you use it? Can you play with it? Can you try it? Yes. There is a lot of different tools that probably nobody knows or you don't know. The configuration can be a little bit tricky. So Michael Kremlin, yes, suggested, well, why you don't do Minipod, that is basically Minikube. So kind of an instance that is run on one node, so you can play with it. So there it is. Minipod is basically a service mesh. What I described before, all these console, nomad, traffic components, everything, that is running on a single node. So you can install Minipod as a package. There is one script that will change some configuration file on your machine, and then you can start it, and you have the same environment on your machine. So you can, it's not for production, not at all, because you don't have high availability and fault tolerance, of course. It's running only on your machine. But anyone can try. So if you want to give a spot, this is the way. There is a README page with the instruction how to install it. It's not for production. If it's not clear, it's not for production. Questions so far? Don't be shy. I still have 5 socks. So. Want to see a demo? You sure? We'll see. So this is how Minipod looks like. I have Minipod running basically on my laptop, and what you have console running on port 88,500. You have Nomad running here, and you have traffic. This is the front end. Actually, we won't use it, but it's here. So how it works, where it is, example, FOSDEM. Yeah. Now I'm. So this is a job description file. So on Minipod, you specify data center just to know where can be spawned, but there are internal abstraction of abstraction. That's the very hello world example. So basically, just define a service called hello FOSDEM. The configuration is Nginx. I mean the standard Nginx. So we will see the standard page of Nginx, where to download the image, which one, which version, blah blah blah, and the port 80 will be mapped to outside. And that's it. That is the minimum thing that we need. So how it works is that we just say nomad run FOSDEM.job. Come on. And the command line tool is now speaking basically with the server, say, hey, this is the job description.
No, I was going to make a question. In the previous config, can you show the copy? I think it's so I noticed that you were specifying the CPU and memory.
Oh, the resources.
RTDL in the kernel to limit the resources of the jail?
So the question was about the resource limitation. Yeah, I missed that point. So basically, I'm using CPU set, so that it's complicated. Theoretically, the resources that you specify are used by the orchestrator to understand if your cluster has the capability to run this kind of job. So the CPU is kind of a bogus megahertz. So if your machine is running on 2 gigahertz and you say that your job needs 100 megahertz, it's basically, okay, your machine is 2 megahertz and then it's using, like to say, 5%, something like that, but it's bogus somehow, and it's used mainly for scheduling and orchestrating. Memory is, I'm using RCTL to enforce memory, but it doesn't work like in C groups. RCTL is trying to limit the amount of memory used by your jail, but if your jail needs more memory, it won't kill your processes. And that is not ideal in general, because then you can have people exploiting that fact, so you can use basically more memory, invading the others. It had this neighbor effect, so-called. One thing that you have to work on is OM killer, so basically trying to monitor the memory consumption. If it really is not able to stick to that value, you have to kill it. But those are resources that are with RCTL and CPU set, basically, they are enforced. I said now, yeah, we have the submitted the job, triggered, created, blah blah blah. What that means, we just look now at the UI here. So that we have our FOSDEM job 1 up and running. And you see there was only one instance. It's running where? Is running here. That is basically where it's reachable. Just click on it. And then there is the welcome to Nginx. We have the same information here. Basically, the service is registered. We will have also some tag, because then you can basically subscribe to specific service that has this tag and so on. And what you have here, you have also basically now console is keeping this information up to date. So you know, he knows where it's running. You see there is not port 80, but this weird number. And then it's performing continuously checks. So if that disappears, that will be marked as red. And basically you can ask to console, okay, give me all the services and give me the services that are in healthy and not running. So this it's trying to keep this information always up to date. And then you have also here, basically, this is traffic. This is this proxy. It receives the information from console, and it had that here a new front end called Hello FOSDEM, because that was the name of the service. And if you basically curl with this host header, it will be redirected to the backend Hello FOSDEM that is here. And those are totally dynamic. So basically continually asking console, oh, there is a new service, is adding a new front end, and is adding then a new backend to serve this this service. I see that I have to run. I have another demo, but yeah, I don't have time to show it. It seems nice, seems working. But what is the problem? Creating the image is actually an issue. I mean, what is the image? How can I create it? How can I provision my jails? We need to provide automation, reproducibility. That's a heavy topic for me. Has to be fast. The images should be not gigabytes, but reasonably small. The solution should be portable and usable. Portability, especially because the current solution is basically flavor. So when you run a pod create to create a pod, you can specify flavors that are basically provision scripts. So you can say, okay, if you want Nginx, boom, I have a script that just install Nginx. I make Nginx an example, but and then you can have basically multiple flavors that do just small set of operations. For instance, there are two flavors out of the box: FreeBSD update and Slim. FreeBSD update is running FreeBSD update before anything. So it's because when how it works when you say, okay, this is the base 12.1, is downloaded the base.txt, but that doesn't have any patches. So you always have to run a FreeBSD update there. And the Slim is a work in progress. It's tried to reduce the image of the size of the image, deleting CLang, deleting a lot of files that if you're running web server you don't need. You don't need GDB, you don't need a lot of things. So I'm just removing hundreds of megabytes of stuff that's in that scenario you don't really need. Two problems. First of all, it's not user friendly. Scripts it's not really user friendly. It works obviously only on FreeBSD. What is a shell script that uses JS? It works only on FreeBSD. What developers use, they don't use FreeBSD. Period. So, I have a FreeBSD. I'm the only one in Trivago. We have 1,000 people. I'm the only one with a FreeBSD laptop. Nobody. Few people use FreeBSD on the laptop, so it's an issue. And the other thing that is not really nice, if you let's say, oh, new version of Nginx, you have to recreate everything from the scratch. So you keep your flavors there, basically those bootstrap scripts, but then you have to create everything from the beginning. This is still an issue. The second one is not that bad. Can be better. Pod machine. Esteban again. Why you don't imitate Docker with Docker machine? So basically, if you want to run a Docker container on a Mac, inside Docker there is Linux binaries, but they run on a Mac. And how it works? Basically, what you have is, you have to install Docker machine that is installing a Linux kernel in a VirtualBox or in a VM, essentially, and it's executing Linux code there. So why can we not do the same? And Pod Machine is this project to create, basically it works on Mac OS X and on Linux. We use Vagrant to spawn a FreeBSD VM where you can execute and run your jails. It extends all the commands available on Pod, so basically you have 2 or 3 commands more, and every command that is not special, kind of, you have Pod Machine, 2 or 3 commands. The other are just forwarded to the FreeBSD VM, and you can have your JS running on Linux, more or less. So it's an important thing because it's breaking the barrier, so everyone can theoretically now play with JS. You don't need a FreeBSD installation to play with JS. The second work in progress is Podfile. We are just looking how it goes. So we're trying to imitate Dockerfile. Instead of having that complicated scripts that you put there and there, you can just have this typical run from whatever. It's experimental. It's not adding really or changing the way. It's just translating this pod file in a flavor. I mean, the flavor is what actually you want to run. Is the same. It's not user friendly, so there's basically a wrapper where people is more used to use to create pod images. I would encourage you to try it. If you have some issues, he will fix them. But I say it's a work in progress, so we are still evaluating. We don't want to create a complete new format because I don't think it makes a lot of sense. But I mean, also Dockerfile is not the best format ever, so we are kind of puzzled what we can do, what we shouldn't do. Registry. Easy. It's HTTP server with those files you put there. So when you do a pod export, you create your image, and then you have those files. You copy them over. Period. You have to maintain your own registry, basically. I don't want to maintain any registry at all. I don't like the idea to download binaries. I don't want to maintain, to have the burden in terms of security of having binaries floating there and there. But I'll be more than happy to have a flavors catalog. So you need Nginx. Okay, this is the way to create Nginx. So you have those scripts already prepared. There's already a process similar to what FreeBSD is doing. They have all these templates where you can just say, okay, I want a jail with memcache. Boom, done. You don't need really to understand how it's already there. So there you have a really a great approach, and maybe I can reuse those templates. I don't know. I have to speak with the FreeBSD developer. This kind of registry that I showed in the examples is a virtual machine running somewhere, is a web server with those two files, period. It's good for example, so you don't have to create your own and so on, but it's not for production use, not at all. Basically, it's just something so people can try it. You can try it, you don't need to create a new image, and so on. But it's not Docker Hub. You cannot upload things. It's a web server. It's not for production. Wow, 2 minutes, 3 minutes. We want to do a lot of things. Many already spoken, but I'm running out of time. We want to focus now more on image creation, because that is where people can then use it, or at least try to use it. Because if you have, you have your service mesh, but you have nothing to run, doesn't make any sense. So this is more or less, especially with pod, we have many ideas, but no time to do it. The dual stack support will come. I get, no, it's not here, Olivier, spoken with him. Good idea to have IPv6 support. Currently, everything is on IPv4, but we will have IPv6 support to provide dual stack, so your container can will speak IPv6. Really thank you to be here. Thank you for listening. I will thank also my contributors. I put nickname because I'm not sure that they want to be, I can write their name, but really thanks. Question? Wow, many. And there's another one. I'm almost over. But I guess I have time for many. How many questions can I? I mean, I will.
For the questions. One or two.
Do you have any ideas about persistent storage?
It's relatively easy. It's not managed here. Basically, you can go on the machine. You can mount datasets or directories inside the container. So it's up to you what to use. But if you have on a specific node, you can pin basically a container running on a specific node where you have a dataset, your persistent storage there, and then you can mount it inside the jail. It's a feature I didn't show, but it's there.
And you can define that this container, this jail has.
Yeah, you specify mount in. You can mount in, as I said, a folder or ZFS dataset in read-only, if it has to be read-only only, and then you can pin the job directly to a specific machine.
Does it run next to IO cage on the same box?
I don't see why not. I use PF. I don't know if IOCage is using PF. I only think what it's doing is using 2 anchors that I add, and that's it. So I don't really pollute too much. And then I have my specific data set you specify where to put your root, where to create all the data sets, and if it's different, then it should be compatible. I never tried it, but keep me posted.
Okay. Last question.
So how would you compare that to the Docker orchestrators like Container or Launcher?
Yeah.
What is better with your approach?